So question number 1 was, which choice best describes the function y equals 6x? And the answer is C, it's an increasing function. So all exponential functions are increasing if a is greater than 0 and b is greater than 1. Number 2, a radioactive sample with an initial mass of 1 milligram has a half-life of 9 days. What is the equation that models the exponential decay A for the time in 9-day intervals? So most times we would suspect that this would be A equals 1/2 9 over t. But because time represents an interval of 9 days, it's actually A. So which is A for that question. Number 3, A equals 90 times 1 over 5 to the x. And it can be written as, so all you're doing here is, that's 5 to the negative 1. It's just a simple exponential rule. All right, you can take an exponential function, you can change it to a negative or a positive by moving it above or below the line. Number 4, for the exponential function, y equals 100, 1/9 x, which of the following statements is not true? And because it's a fraction, it's no longer an increasing function, it's a decreasing function. All right, because as x gets larger, your y gets smaller. So it's a decreasing function. So the answer is, which one is not true? A is not true. Number 5, solve for x to 1 decimal place. Okay, so there's a couple ways in which you could do this. You could graph it, which is fine. Take the log of both sides. Move that x down in front, so I get x is equal to log 733 divided by log 5. And the answer for that is 5 was D, 5.5. I'll go through it relatively quickly, so if you have questions that you want to ask, you can ask. So I've got 36 to 3x, 216, x plus 7. So that's 6 squared, or 6 to the 6x, equals 6 cubed. So that would be 3x plus 21. 6x equals 3x, add 21. 3x equals 21, x equals 7. So that's B.
This next one, I didn't know how to do.
Okay, let's go through it then. I think you're just substituting in, but let's check it anyways. The half-life of a radioactive element can be modeled by m equals m naught, 1 over 32, t over 45, where m naught is the initial mass of the element, t is the elapsed time in hours, and m is the mass that remains after the time t. So the half-life of the element is, okay, so you can put whatever you want in as your initial amount. So let's put 10 in as your initial amount. It doesn't matter. That means that the m amount we want to know is half of that amount. So it's 5. So if I just hypothetical numbers, I'm just going to show you 5 equals the initial 10 times 1 over 32 t over 45. Just like that, okay? Now I'm going to do this. There's an easier way to do this, but I'm going to show you the little bit longer way of doing it. So here's why I can put anything I want in here, as long as when I divide this over to here, I end up with 1/2. That's my intended goal right there. All right, is to have the half-life. So whatever the initial amount is, I got to have half of it when it's said and done. So that equals to 1 over 32 is the same of 1 over 2 to the power of 5 t over 45. So like that. So this is an exponent 1 here. This becomes t over 9. 5t over 45. 5 divided by 4. 5 divides into 45 9 times. The answer for the question is 9. It's going to take 9 hours. So that's doing it all without any technology, any work, any calculator. All right. So again, whatever this is divided into this has to equal 1/2. That's the important part, because it has to be half of what it was. And as it turns out, 1 over 32 can be put into the base 1/2. 1/2 to the power of 5. Power to a power, 5t over 45 is t over 9. That exponent right here has to equal 1. T equals 9. This next one, as long as you're okay, I can slow down if you need. This next one, Lot's got this one wrong. Number 8. They say it's D. Okay, so I'm going to do this a little different.
I thought it was 6.
1 over 6 to the x. Okay, so if I were to just take a look at the graph of this, all right? So if I did 1, that would be 1/6. If I did 2, that'd be 1 over 36. If I did 3, that would be 1 over 216. So that's going to be going down, right? No, it's actually... Okay, now I've got to decide what's going on here. So if I put a -1 in there, that means that's 6. So it should be like this. -1 would be 6. -2 would be 36. -3 would be 216. So that graph should look like this. And that's 0 and 1 still. C somewhat looks like it could be right. Yeah, because it definitely can't cross the line on D. I'm not sure why they have that as D. Anyways, I'll just exclude that one probably. But the answer to this, I think the closest thing to it would be C. Okay? So I'll look at that again when I go back through. Because there's a few that I think I marked wrong. Okay, number 9. The range for the following. So I've got f of x. All right. So if I were to fill in A, B, C, and D. So So A is -8, B is 10, C is -8, D is 9. And let's just focus on one thing right now. That's the log of this graph right here. Okay? So the log of x to the base 5 would be this graph right here. Well, what's the range of that graph? That graph is -infinity to positive infinity, which is y is an element of all real numbers. It doesn't change. No matter what happens here, my graph is still going to have an infinite, -infinity to positive infinity, or a range of y is an element of all reals. Okay, so that's 9. So for a logarithm graph, your range is y is an element of all reals. Doesn't matter what you do to it. In B, or in 10, sorry, 10, the equation is a little different, but it's now asking for okay, so A, B, C, and D again. So A is 8, B is 8, C is -8, D is 7. Okay, so we've got that log graph again. So now, because I am focused on my domain, this is the important guy right here. So which one, A, B, C, or D, has an effect on this? Well, A, I multiply the y values by 8. Doesn't affect my asymptote. B, multiply my x values. Same thing, doesn't affect the asymptote. C affects the asymptote. It moves it over to here. So that means then that this graph, no matter what this graph looks like, the domain for this graph x has to be greater than -8, where x is an element of all reals. Okay, so that's D. What is the equation for the asymptote of the function? So we just looked at this. So C is the, in a logarithmic graph, C is what affects the asymptote. So if I'm looking at A, B, C, and D from question 11, I got A is -1, B is -5, C is -2, D is -3. C is what affects the asymptote in a logarithmic graph. So my equation of my asymptote is x equals -2. And that is D. All right. Short answer, question 1. I have y equals 3x minus 2. So I have an exponential graph now. B we don't worry about. Well, yeah, we do. Sorry, my bad. C and D. So A, 1/2. B, 1. C, 2. D, 0. Okay, describe the transformations of the function when compared to the function. So my transformation is a vertical stretch by a factor of 1/2. And moves right 2.
Isn't it a vertical regression?
Well, but okay, here's the thing that I have an issue with. And that is this, is that if you call it a vertical compression, then you're calling it a vertical compression by a factor of 2, right? Or you're stretching by a half. Like you can't say that you have a vertical compression of a half, because it's kind of like being redundant as far as I'm concerned. So I always just say everything's a stretch, and I put it by a factor of a half. Yeah, that means that my y values are going to decrease, but so what? It's by the same factor, so I can't get that wrong. But if I say it compresses by a half, now I'm saying that I'm shrinking it by that factor, and I don't think, like, I don't know. I'm sure that, like, I know in the assignment, on the assignment, they say that it's a compression by a factor of a half, but to me, I feel like it's a compression by a factor of 2, because compression means you have to divide by. So if I'm doing a compression by a half, then that means I'm dividing by a half, and then, which is then a stretch. So I don't know. It comes down to semantics. I'm not going to say either is wrong. I know that the book would say a compression of I think a half. I can't remember. But whatever. The other way you can do it is you can say you're going to multiply your y values all by a half. That's one way around using the word stretch and compression, saying you're going to multiply all your y values by a factor of 1/2. I would accept that as being right as well. Okay. Now it wants us to graph it. All right, so let's take our original. So 0 and 1 is important. Asymptote is important. Again, when you're doing graphing technology, your asymptotes don't show. You've got to show those on your sketches. Okay? So 0 and 1 now becomes 0 and 1/2, right? And then I have to move it right 2. So now that becomes 2 and 1/2. So somewhere over here. And now what I want to do is I want to find out what that guy is right there. So I've got y equals 1/2, 3 to the x minus 2. So y equals 1/2 times 3. I put a 0 in for x, so that gives me a -2. That gives me 1/9. So that's kind of what I want right there. I would expect you to have that as 0 and 1/18. Okay, as my y-intercept. All right. Doesn't ask for it in here. It says state the domain. So what's the domain for this graph? No, I did this wrong. Yeah. Domain, there, x, element of all reals. Okay. Range for this graph.
Is it all right if we put, like, I have the, like, x is an element of all reals, but I put -infinity to positive infinity. Does that matter?
Yeah, if you do it like this, that's fine. As long as you have those brackets as open brackets. Yeah, that's okay too. Yeah. Okay, and the equation of the asymptote. Y equals 0. All right. Okay, question 2. Log 64. Log 27. log of 250, 1 over 256. What is that? 1664, 234, I think. Like that. Okay? So, again, I'm looking at this question and I'm saying, well, hey, wait a minute. 64 can be put to the base 2, 27 can be put to the base 3, and 256 can be to the base 4 as well. All right? So, now, move these all to the front. That gives me 6 plus 3 times -4. 6 plus -12. -6 is my solution for that question. Okay? All right. 3. Okay. So here's one with a bit of work to it. All right, again, this is one of those ones that I said, if you were to write that provincial exam this year, you would see this for sure. So I'm going to go 3x plus 1 log 6 equals 2x minus 3 log 2. So basically what I'm doing here is I'm taking the log of both sides and I move those exponents down. Distribute through your brackets. 3x log 6 plus log 6 equals 2x log 2 minus 3 log 2. Okay, get the x's on one side. 3x log 6 minus 2x log 2 equals minus 3 log 2 subtract log 6. So subtract 2x log 2 over, subtract log 6 over, factor out my x.
I can't see. I think you need to adjust your phone.
I need to adjust it.
No, you're good now. It just zoomed really close.
Okay. Minus 2 log 2 equals minus 3 log 2 minus log 6. And then I have to divide. Minus 3 log 2 minus log 6 divided by 3 log 6 minus 2 log 2 equals, and oh, I do have it here, minus minus 0.970. Okay. Again, we did this in applied math, so it's not really new. So the expectations are that you would be able to do that and complete it. Okay? Number 4. So on that one, we are changing from exponential to logarithm to solve it because our x value is an exponent. On the next one, our x value is in the log part of it, so we need to change it to an exponential. So here's what I have. Log x plus 4 squared base 4 minus log x plus 12 base 4 equals 1. So in order to change it to exponential, I need to change this into a single logarithm. So I'm going to go log, and that's x plus 4 squared base 4 over x plus 12 equals 1. X plus 4 squared over x plus 12 equals 4 to the power of 1. Multiply the x plus 12 up. X plus 4 times x plus 4 is x squared plus 8x plus 16. Get it all equal to one side. Oops, missed one step here. X equals 8. No, sorry. Got my signs wrong here.
That's backwards.
Signs backwards. Plus 8, negative 4, that's a negative 8. And plus 4, and the negative 8 doesn't work. So x equals 4. All right. Another question that we've done something similar to and applied as well. Okay, problem number 1. Got a sketch, f of x equals 3 log that. So let's do A, B, C, and D. A is 3, B is 1, C is 1, D is 4. So we'll focus on 1 and 0 to begin with. Times it by 3, so it still becomes 1 and 0. Do nothing with it for B. C is move it right 1, that becomes 2 and 0, and then 2 and 4. So 1, 2, 2, 3, 4 comes up to here somewhere. So I've got 2 and 4. My asymptote moves over 1. Right there. That's what she looks like. Okay. And I probably should find out what that is. All right, that intercept. So I put 0 in here. 3 log x minus 1, add 4. So I would subtract 4, so that's going to give me negative 4, and divide by 3. Negative 4 thirds equals log x minus 1. Convert that to an exponential function. So I'd end up with x equals 10 to the negative 4 thirds, add 1. So that would be that intercept point. Now you could use your technology at that point, at that instance, and find out what that was. So using algebra, I could find it, but using your technology is fine. So it says identify the domain and range. Domain is x is greater than 1. Range minus infinity to positive infinity. And the equation of the vertical asymptote x equals 1. Okay? All right, girls. And this one, log 7, is approximately 0.8451. Log of 2 is approximately 0.3010. And it wants the log of 28. So that's the same as the log of 7 times 4. Split those up. Log of 7 plus the log of 4, which is 2 squared. So that gives me the log of 7 plus 2 log 2, or sorry, plus the log of 2. So 0.8451 plus 2 times 0.3010. And that equals 1.4471. Okay. Questions about it? No? Okay. So, I'm going to start chapter 11 tomorrow, which means you have to get that assignment in today. So I want that turned in. And that takes care, if there's no, girls, do you have any other questions about that before I shut off the YouTube here?
Not with the assignment, I don't.
Okay. Anything out of your workbook? Good. All right. Quick peek at physics.